open your book to page 290. This is lesson 10.5. This lesson is on distance problems. So when you're doing the distance problem, first you need to do is draw the picture based on the story, and then you need to make a table. And when you're making a table, again, you do the same thing. So what you need to do is, when you have the table, right? So whatever amount inside. So again, the name of the trip, the names, you always want to make the name goes across on the top, and the formula always go up and down. Okay, so that would be a little bit easier. So in this case, for the distance problem, is the r times time equal to distance. So r is the speed or the rate, like miles per hour. Time would be, t would be for time, like how many hours or how many days. Most of the time is hours. And d would be distance. Okay, so again, the speed times time equal to distance. Now the distance usually is in miles, but again, you have to read the problem to figure it out. Okay, so let's go over example 1. And again, what you want to do is you want to first. Sometimes you might, you have to read the story a couple times to get a good understanding of the story. Okay, so let's go to example 1 on page 291. It says, Mr. Maxwell take 2 hours to drive to airport in the morning, but he takes 3 hours to return home over the same route. Okay, so over here, so you have the home over here, and he drove to the airport in the morning. So this is in the morning, so let's call this AM, and then in the PM he's coming back, okay, on the same route. Okay, so this is the PM. So AM is going, PM is coming back. Okay. Now let's go back and read again. You have to read the problem several times, okay, to get all the information. It says Mr. Maxwell take 2 hours. So in this case, t equal to 2 hours. Now you want to, so if it's for the morning, you want to put on top. If it's the PM, you put in the bottom. Don't put anything in the middle, because if you put in the middle, you're going to get confused. You're not going to know if the middle is for the top or for the bottom. So leave over here blank. Okay, so don't write anything in the middle, because again, you write in the middle, you're not going to, after a while, you're going to forget if it's for the top or for the bottom. So if it's for the top, right above. If it's for the bottom, right down here. So that way it's very clear that information is for here or for here. Okay, now continue to read. Again, read every part and process every information. But he takes 3 hours to return home. So t equal to 3 hours coming home. Okay. Now it says if the average morning speed is 20, so the speed, so it's r is the speed, right? So if the average speed is, right? So average morning speed is 20 miles per hour, faster than means plus. Again, you need to know how to translate, right? So 20 miles faster than means plus, average evening speed. So you don't know what that is. So let's go and call this r equal to x. So that way it's 20 miles per hour more than this would be x. Okay. So you want to use the second item as your reference. So again, so the morning speed is 20 miles per hour more than the speed in the evening. And again, you don't know what that is, you put an x, right? So again, whatever you don't know, use variable. Okay, and so it's how far, so you're looking for the distance. How far is home to the airport? So you're looking for the distance. Okay, so you can make sure you draw the picture, it helps you to visualize. Okay, so now let's go and draw the table. So this one, all you need to do is have 3, actually it's 4, okay? So again, the formula goes over here, so r times time equal to distance. So over here you have going, or AM. Let's go and call this AM, or the going, right? You can do either way, and this is return. But so it's the PM, so in afternoon. So whatever you do, just make sure it's clear, okay? Okay, so let's go and start to fill in the blank. R is the speed. So if you look over here, the speed in the morning, I'm going to write it in the correct order. So over here, so I'm going to write x plus 20, okay? And in the evening it's x, right? Again, that's just speed. The time in the morning it tells you is 2 hours, and in the evening it's 3 hours, okay? So again, you multiply, you always multiply down the column. So when you multiply, okay, so 2 times x is 2x, 2 times 20 is plus 40. This one is 3x, right? Then next what you do is for the distance formula, you have to figure out what's the relationship between the distance. So this is the distance for going, right? See the going distance, right? So this is the distance for going. This is the distance for coming back. Okay, so you have to read it. So it tells you on the same route. So if you look at this picture over here, this is the distance going, distance coming back. So they are the same. So in this case, the distance going equal to the distance coming back. Again, this is the distance going, this is the distance coming back. So when you're going in the morning and you come back the same route, they will be equal, right? So the key to the distance formula is figure what's the relationship between the distance going and distance coming back. Okay, not always equal, it all depends on the story. So you have to kind of read the story to figure out what is the relationship between them. So we're going to cover more examples as we go. Okay, so from here again, now you have to solve, right? So minus 2x, so it cancels out. So you got 40 equal to x. Okay, and make sure you answer the question. Okay, so this is not a question. Okay, this is only the speed. Okay, this is only the x. So you have to figure out the distance. So you can use either one. So don't box that yet because you're looking for the distance. You're looking for this right over here. Okay, so this is the speed, but that is not the answer because it did not ask you for speed. It asked you for how far. So it asked for distance. So you can use this or you can use that. So this is probably a little bit easier. So the distance equals to d equal, right? So d equal to 3x, right? Again, you can use either one, but this is probably a little bit quicker. So d equal to 3 times 40. So d equal to 120, and the distance would be miles. Okay? And that would be your answer. So again, first, read the story, draw the picture correctly. And all the information should be on the picture. And after that, you make the table, fill in the blanks, and figure out what's the relationship between going and return. Figure out what the relationship between the two distances. Okay, again, this one is going and coming back on the same route. So that means that distance is equal. So you set equal, you solve. And again, make sure you answer the question. The x is the speed, but that is not what they ask you for, right? They ask you for distance. So you can use this one or this one. Both are the same. Okay? And so the answer would be 120 miles. Okay, let's go to example 2. So you can read the story to get an understanding. It says 2 trains are 600 miles apart. Okay, so I'm going to call this train A, train B, and the distance is 600 miles apart. Okay, right? Again, so 2 trains, they are 600 miles apart. And they're traveling toward each other. So it's draw the arrow. Okay, so they're going to travel toward each other, and obviously they're on a different track, right? So, you know, there are 2 tracks, so they don't collide, right? So train A, the speed is, so R equal to 50 miles per hour. Okay, and train B, the speed equal to 70 miles per hour. Okay, again, so make sure you keep that, right? So this is the B, this is the A, right? So how long, talking about time, so time, right? How long time will it take the trains to meet? So again, let's start over here. When they meet, that means the time are equal, right? So the one thing you have to remember, okay? One thing you have to realize. So you can make the table. Okay, so this is train A, train B, so it's R times time equal to distance. Okay, so you can start to fill in the blanks. So over here, train A, the speed is 50, right, over here, that's the 50. Train B, the speed is 70. Time you don't know, so put an X. Then B, again, you have to ask yourself, are they the same or different? If they're the same, use the same letter. If they're different, use different letters. So if they're different, use X and Y. But in this case, they start at same place, same time, right? So you get toward each other. So when they meet, they would be same time. So it would be same letter. Again, so you have to read the story to figure out if they are the same or different. If they're the same, use the same letter. If they're different, use different letters. So you can multiply. So it's 50x multiply 70x. So you have to look at the picture. What is the relationship between the distance? So this distance is this here. Okay? This distance is this over here. So what's the relation between it? Well, if you notice that this and this equal to total of 600. You see that? So you have to kind of look at the picture and really have to really understand the story. So again, you have to read to figure out what, sometimes they are equal, sometimes you have to add equal to something. So in this case, the distance for A plus the distance for B will equal to total, again, equal to total of 600. So again, you have to read the story to figure out how to figure out the equation. So the distance problem, it takes more thinking. Okay, so now let's go and solve. So you get combine the like terms, right? So you get 120x equal to 600. Divide by 120, divide by 120, so x equal to 5, and the time is 5 hours, right? In this case, and that's your answer. So the time would be 5 hours. Okay, let's go to example 3. Example 3 is another type. So 3 examples are 3 different types of distance problem. Okay. So example 3 is a boat. Okay. So draw a boat, and it's cruising downstream. So that's why you're going down, right? So cruising downstream for 4 hours. So t equal to 4 hours. Because of the stream's current, it takes again when you're going downstream. Notice the water. The water always going down, right? The water always going downstream. It will never go upstream. Okay? Okay, because of the water, it takes 5 hours to get back upstream. So when it reaches this point, it's going to turn around and it come back. Okay? So it get back over here. But because the water pushing against it, so the time coming back is 5 hours. Okay? And it tells you that the speed of the stream, so the water, is equal to 3 miles per hour. Okay? And find the speed of the boat. So you're looking for the speed of the boat. Okay? Not including the water. Okay? So again, that's a picture. Again, going downstream, going upstream, right? And there's the water. Water is always going this way. So now when you have the upstream, downstream, or you have a wind, okay, then when you make the table, so again, this R times time equal to distance. So this is going down, and this is going up. Now the speed, what you need to do is, when it's going downstream, you're going to have the speed of the boat plus the water, because the water is going to make it go faster, right? So the water is 3, so you have to plus it 3. So again, going down, when you're going downstream, you have the speed of the boat, and plus the water. Again, the water is going to make the boat go faster, right? See the 3? Okay, so it's going down. Notice the arrow going in the same direction, so it's going to, you have to add. Okay, the time is 4 hours, right? Tells you going downstream, right? Now, when you go upstream, you have the speed of a boat. When the boat is going up, but the water is going to push it back, so you have the minus, right? So again, when you're going upstream, the boat is going up, but the water is going to push it back, so you have the minus. So going downstream, the water is going to push to make it go faster. That's why you add. When you go upstream, the water is going to push it back to make it go slow. So you have to minus, and the time is 5. Okay, and again you multiply, so you got 4b plus 12. This one you get 5b minus 15. Again, for the distance problem, you have to figure out what's the relationship between them. So this is the distance. See the d, the distance. So that distance going downstream. This is the distance going up. Notice it go downstream, it come back up, right? So they're same. They're equal. See, just like before, right? See over here, when you have this kind of situation. When you go and come back, they are equal, right? But when you have this kind of situation, when you go toward each other like that, you have to add to equal to the total. So again, you have to kind of, that's why you want to draw the picture, read the story to make sure you really understand. So in this case, the distance going down equal to the distance going up. Okay? So now you have to solve. So minus 4b, again, you always do the variable first, right? So minus 4b, so you got 12 equal to b minus 15. Then you plus 15, plus 15. So you got b equal to 27, and the label would be miles per hour. Okay, and that's it. So that's the speed of the boat, not counting the water, just the speed of the boat by itself.